What happens when pieces of the Earth's crust move? Through this PowerPoint, we're going to go through all of the plate type boundaries and stuff. So those notes, you'll be filling in some of it. There's extra information, so if you want to take extra notes, you can. So the first part is just talking about what a tectonic plate is. Well, they're constantly moving, and they move very slowly, centimeters per day, if even that. So it's not something that you're going to realize very quickly is happening. It happens over a slow period of time. So as those plates are moving, sometimes they're pushing against each other, sometimes they're pulling apart, and sometimes they're sliding by each other. So here's a nice illustration of all the different plate types. These are just some larger ones. There's a lot of smaller ones that aren't listed here, but it kind of gives you an idea of these plates. So if you look at the arrows, they kind of give you a little here in the key, where these ones are pushing together, but also sliding by each other. And here, when you get down here, these ones are pulling apart. So you can kind of see all the different ones along here. Boundaries are places where tectonic plates meet. And our three types of boundaries depend on how they move. So if they pull apart, we call them divergent. If they push together, we call them convergent. And if they slide by each other, like scraping by each other, we call them transform. So a convergent boundary. This boundary is formed when two tectonic plates collide together and crust is destroyed, meaning we lose crust here. Okay, so with a convergent, crust is destroyed. There are types of convergent boundaries. So you have continental and continental crust that are pushed together, and those are where mountains would form. You have, so examples of that, your Himalayas, where these ones came together. You lost crust because this is losing crust here, but we gain mountains. Nice pretty picture of them. All right, another one would be continental and oceanic crust coming together. So here, the oceanic it's part of a subduction zone. You have a trench. It's going underneath the continental crust, and on this border where these two boundaries come together, this is where you're going to see volcanic activity. You're going to have those volcanoes. So here's some examples looking at some other. You can see off here on the west coast around Seattle, we have it's convergent boundary, so we have volcanoes. You can see it also, that same going down South America, we have the same thing, more volcanoes. Okay, we have our Andes Mountains. Another type of convergent boundary would be when oceanic and oceanic crust are coming together. And here we have volcanoes that form, but they could be islands. And a great example of this would be your Hawaiian Islands. Also, the islands off Alaska. So lots of great examples of the three types of convergent boundaries. So just kind of to recap, you have where you have oceanic and continental crusts come together. And when that happens, you get volcanoes. You have oceanic and oceanic converge, and when that happens, you'll just get islands and volcanic islands in the ocean. And when you have continental and continental crust converge, that's where you see mountains. So subduction, that takes place at these convergent boundaries, meaning one plate is going under another. That plate will sink, and so the regions where those convergent boundaries occur, we call those subduction zones. They are going to occur at those oceanic convergent boundaries or the oceanic continental boundaries. Convergent boundaries, also remember the volcanoes are a result of these subduction zones. So again, just to kind of go over them. So CC, continental crust, means you get mountains. If you have oceanic and oceanic crust, or continental and oceanic crust, you have a subduction zone. If you have that same result, you would also see volcanoes. If you have just oceanic and oceanic, you might see island volcanoes. And lots of earthquakes, of course, and crust is destroyed. That's the biggest thing. So on to our second type of boundary, is divergent. This boundary is when two tectonic plates move away from each other and new crust is created. So while convergent destroyed crust, divergent creates new crust. So types of divergent boundaries. So you have oceanic and oceanic crust. When those are pulling apart, you'll see an oceanic ridge or sea floor spreading, such as the Mid-Atlantic Ridge, which you would find out in the Atlantic Ocean. And this is a boundary where those two oceanic and oceanic plates are moving away from each other. When you have continental and continental crust that are moving away from each other, you get what's called a rift valley. You can see a picture here of one. The East African Rift Valley. They're formed from two divergent continental plates. Just looks like a big hole going down into the earth, basically. Iceland is another great example of a divergent boundary. You can see it just, that plate goes right through Iceland. So, divergent boundaries. Oceanic and oceanic crust, you have seafloor spreading because they're pulling apart, and because of that, they create what's called a mid-oceanic ridge. When you have continental and continental crust pulling apart, they create what we call rift valleys. You will see evidence of volcanoes and low-lying earthquakes, meaning they're kind of more underground and not shaking so much on top. But the biggest thing with divergent is we have new crust created. So our third type of boundary is transform boundary. And this is between two tectonic plates that scrape past each other horizontally. So they're just sliding by each other. But when they're sliding by each other, they're creating friction. The San Andreas Fault in California is an example of a transform boundary. You have one plate that's moving up and the other one's moving down. It's another illustration of that San Andreas Fault. You can see it here. A lot of people have, conspiracies that, hey, Los Angeles is going to just fall on off. Well, that's not exactly how it happens. It's a creep, a slow thing. I mean, it moves centimeters in a year. It would take approximately 10 million years for those cities to ever be near each other at the rate it's moving currently. You can see some evidence with the earth here. And you can see the different tones. So plates separated by a transform fault do not glide past each other. But remember, I said there was friction. Those rocks are causing the plates to lock. There's friction. They're pushing. They're pulling. They're snapping. It's just a sudden release of energy, and that's when we feel the earthquake. Lots of earthquakes. So looking at the world here and looking for patterns of major geologic events such as earthquakes, volcanic eruptions, mountain building, you can see that they coincide with these plates. So the blue dots are all where we've had a lot of earthquake activity. The red triangles are volcanic activity. You can see those. And this that they call is the Ring of Fire because there's so much volcanic activity and earthquakes around this. And that's why it got its name. Whoops. Here's another showing you some different illustrations of divergent, convergent. You can see the plates are here moving towards each other. This one's moving that way, so that one's moving that way, away from each other. So that, and then you can see that here's like a transform boundary. So back to the Ring of Fire. Basically, it's a ring of volcanoes around the Pacific Plate. This is a result of the subduction of the oceanic plates beneath that lighter continental crust. Okay. It's just kind of another illustration of seeing that ring of fire. Another one, you can really see all that activity from volcanoes and earthquakes. And also, if you want any review songs or anything, I can share these with you. You can look them up. It's up to you. I hope that kind of explained the different types of boundaries. Make sure you're taking notes on it. If you have any questions, please let me know.